Hola a todos, bienvenidos nuevamente, soy Cecilia Chávez y el día de hoy daremos paso a la lección 2 de nuestro curso, en el cual estudiaremos las propiedades de la materia y el uso de adjetivos calificativos para resaltar o especificar las características de sustantivos en inglés. Here we go. Lesson 2. Properties of Matter. Objective: differentiate the states of matter based on their properties. Before starting, let's see how much you know about matter. Please help me answering the following questions. Number 1, it says, matter changes its states when heat is added or removed. Here we have two answers, or true or false. Then we say, question number 2, ice and metal are examples of which state of matter? We have 4 options. Letter A, gas, letter B, solid, letter C, liquid, or letter D, plasma. The question number 3 says, air around us exists in which state of matter? We also have 4 possible answers. Gas, then letter B, solid, then liquid, and finally, plasma. For the question 4, we say, the changing of a solid to a liquid is called option A, melting, option B, freezing, or option C, condensing. Now, let's solve the test together. If your answer was true in the question number 1, you are totally right. If your answer for the question number 2, if ice and metals are examples of which state of matter, your answer was letter B, you are wonderful. In the case of the number 3, if air around us exists in which state of matter, your answer was gas, congratulations. And finally, the changing of a solid to a liquid is called, if your answer was the letter A, melting, you are amazing. After taking this short test, you are asking yourself, why studying about matter is so important? Well, for you as students of engineering and architecture, it is important to know the properties of matter, because all things around are made of matter. Each type of matter has different physical characteristics, and you as a student need to know and understand these characteristics to make calculations, not only now, but for your future as professionals too. Look around you. We all are surrounded by matter on a daily basis. Anything that we use, touch, eat, etc. is an example of matter. But do you know what matter is? Matter can be defined or described as anything that takes up space and is composed of minuscule particles called atoms. It must display the properties of mass and volume. But what is mass? It is the amount of matter in an object. It is measured in kilograms and can be calculated with a balance. What is volume? It is the amount of space an object takes up. It is measured in liters and it can be calculated with a ruler or a graduated cylinder. The properties of matter. It is referred to the qualities or attributes that distinguish one sample of matter from another. These properties are generally grouped in 2 categories. Number 1, physical, and number 2, chemical. Physical properties. Physical properties are used to observe and describe matter. Physical properties of materials and systems are often described as intensive and extensive properties. Any property you can see, smell, touch, hear, or otherwise detect and measure without performing a chemical reaction is a physical property. Examples of physical properties include color, shape, volume, density, temperature, boiling point, viscosity, pressure, solubility, and electric charge. Intensive and extensive physical properties. Physical properties may be classified as either intensive or extensive. Intensive physical properties do not depend on the sample's size or mass. Examples of intensive properties include boiling point, state of matter, and density. Extensive physical properties depend on the amount of matter in the sample. Examples of extensive properties include size, mass, and volume. Chemical properties. It is a property of matter that describes a substance based on its ability to change into a new substance with different properties. It is quite difficult to define a chemical property without using the word change. Here we have some examples. Flammability, only when wood burns. Combustibility, only when fireworks explode. Or reactivity, only when iron oxidizes. The different states of matter. When we talk about the states of matter, it is important to understand that some of the words mean that are used quite a lot. One of these words is a molecule. Molecules are made of two or more atoms. Atoms are tiny particles of building blocks which make up substance. Everything you see or imagine is made up of something. So, atoms, when put together, form molecules, which form cells, which form our organs, our populations, our planets, galaxies, and so on. Now, let's study the states of matter one by one. Solid. Solids don't change shape easily. Think of a piece of paper. You can change the shape by crumpling it, but it doesn't change its shape by itself. You have to use your energy to make the shape change. If you put a solid in a container, it won't change its shape, no matter how much you move it or slide it around. Now we have liquid. Liquids take the shape of their container. Liquids have surface tension. The particles hold onto each other, like holding hands with a friend. The skin or surface of a glass filled with water holds together because the particles hold on to each other. That is called surface tension. Liquids move around. The particles in liquids are farther apart than those of solids, so they can move around more. That's why liquids take the shape of their container. Gas. Gas is invisible. That means you can't see it. The particles are so far apart they are invisible, but they are still there. Think about oxygen. You can't see it, but you know it's there because you can breathe it. Gas particles move around freely. Besides the three main states of matter, we can also recognize the following two. Number one, plasma. Plasma is not a common state of matter here on Earth, but may be the most common state of matter in the universe. Plasma consists of highly charged particles with extremely high kinetic energy. The noble gases helium, neon, argon, krypton, xenon, and radium are often used to make glowing signs by using electricity to ionize them to the plasma states. Stars are essentially superheated balls of plasma. Now we have Bose-Einstein condensate. In 1995, two scientists, Cornell and Wyman, finally created the condensate. Bose-Einstein condensates are not like the forms of matter you are most familiar with, such as solids and liquids. This form of matter is not vaporous like a gas, or fluid like a liquid, or hard like a solid. It's very hard to find the right words to describe the characteristics of Bose-Einstein condensate, because it doesn't come from this world. You have never seen it. It is created in the realm of quantum mechanics, also called quantum physics, which is the branch of physics that deals with what is happening inside atoms. Atoms are like the tiny Lego bricks that make up all of the stuff in the universe. Properties of matter include how it looks, shiny, dull, or colored. We can also say how it feels, hard, soft, rough, or smooth. How it smells, sweet, salty, or flowery. We can also say how it sounds, loud, soft, or hollow. Another property, how it tastes, sweet, salty, bitter, or sour. We can also say what it does, bounce or bubble. Now you know that everything is made up of matter and that they have general properties such as the mass and volume, and specific properties such as color and taste, which allow us to distinguish one substance from another. Now it's time to do the activities.